This video explains how to handle missing values using the is.na function in the R programming language. So without too much talk, let's dive into the R code. In the first part of this video, I will show you how to apply the is.na function to vector objects. And for this, we first need to create an example vector, as you can see in line 2 of the code. So after running this line of code, a new vector object called vec is appearing at the top right. And we can print this vector to the bottom in the RStudio console by running line 3. And then you can see that our vector object contains 7 elements, and 2 of these elements are NA. So if we want to identify the NA values in our vector object, we can apply the is.na function to our vector object, as you can see in line 5 of the code. And within the NA function, I'm simply specifying the name of our vector object. So in this case, our vector object is called vec. And if you run line 5 of the code, you can see at the bottom in the RStudio console that a new vector is returned, which contains logical values. And always when this vector contains the logical value false, then the value in the input vector is not NA. And if the logical vector contains the value true, then the input vector contains an NA value. So as you can see, at the second and at the 5th positions of our input vector, we have an NA value. We can do the opposite if we want to check for non-NA values. And all we have to do for this is to specify a bang symbol in front of the is.na function, as you can see in line 7 of the code. So after running this line of code, the logical vector that is returned is reversed. So always when this vector contains the value true, our vector contains a non-NA value. It's also possible to combine the is.na function with the any function to check if there are any NA values in our vector object. So if you run line 9 of the code, you can see that the logical indicator true is returned. We already knew that we have NA values in our vector object. It's also possible to use the is.na function to identify the index positions of our NA values. And we can do that by combining the is.na function with the which function, as you can see in line 11 of the code. So after running this line of code, the values 2 and 5 are returned. And this is because our input vector contains NA values at these index positions. We can also count the NA values in our vector object by combining the is.na function with the sum function, as you can see in line 13 of the code. And as you can see, the value 2 is returned because our vector object contains 2 NA values. In the next example, I also want to show you how to replace NA values in our vector object. And for this, I'm first duplicating our vector object because I also want to keep an original version of our vector. So after running line 15 of the code, a new vector object called vec0 is appearing at the top right. And at this point, this vector object contains exactly the same values and NA values as our vector object vec. However, then in the next step in line 16, I'm using the is.na function to replace all the NA values in our new vector by the value 0. So after running line 16 of the code, our vector is updated, and we can see that by printing this vector to the RStudio console by running line 17 of the code. And then you can see that all the NA values have been replaced by the value 0. So in the first part of this video, I have explained how to use the is.na function for vector objects. However, it's also possible to apply this function to data frames. And this is what I want to show you in the next part of this tutorial, starting in line 19 of the code. So as a very first step, I'm creating an example data frame, as you can see in lines 19 to 21. So after running these lines of code, a new data frame object is appearing at the top right, which is called data. And we can print this data frame to the RStudio console by running line 22. And then you can see that we have created a data frame that contains 6 rows and the 3 columns x1, x2, and x3. And all of these columns contain some NA values. So if we want to apply the is.na function to this data frame, we can simply apply the function to the entire data frame, as you can see in line 24. So after running this line of code, a new matrix is returned, which contains the logical values false and true, depending on the values in our data frame. So by doing that, you get a logical matrix which is always true in case there is an NA value in our input data frame. We can also use the bang operator as we already did for the vector in the previous part of this tutorial, as you can see in line 26. So after running this line of code, the opposite matrix is returned. It's also possible to use the is.na function to count the number of NA values by columns in a data frame. And we can do that by combining the is.na function with the colsums function, as you can see in line 28. So after running this line of code, a new output is returned, which shows that the first column x1 contains 2 NA values, the second column x2 contains also 2 NA values, and the third column x3 contains only 1 NA value. And we can count the NA values by rows in our data frame by simply replacing the colsums function by the rowsums function, as you can see in line 30. So after running this line of code, you get a vector object which counts the NA values by rows. So for instance, in the first row of our data frame, there are 2 NA values, and in the last row of our data frame are no NA values. It's also possible to replace NA values in a data frame by 0, as you can see in lines 32 to 34. I'm first duplicating our data frame because I want to keep an original version of our data frame, and then I use the is.na function to replace all NA values in all of the columns of our data frame by the value 0. So after running line 33 of the code, our new data frame data 0 is updated, and we can see that by printing this data frame to the RStudio console, and then you can see that we have replaced all the NA values by the value 0. That's all I wanted to explain in this video. In case you want to learn more on this topic, you may check out my homepage, statisticsglobe.com, because on my homepage I have recently published a tutorial in which I'm explaining the content of this video in some more detail. I will put a link to this tutorial into the description of the video so you can find it there. If you have liked this video or if you have any questions, let me know in the comments section below. I'll try to respond to all comments as soon as I can. Furthermore, make sure to subscribe to my YouTube channel to get notified about future video releases. I have already published about 500 videos on this channel, and I'm releasing new videos on a daily basis. Thanks a lot for watching. See you in the next video.